we have discussed the topic friction in a previous video, and here I'm trying to explain you a solved problem on the same topic, that is the friction. So what we have already discussed is solid friction, and we are going to do a problem on the same topic. As I mentioned in many of the previous videos, if you are not thorough with the solution, or if you are not thorough how to resolve a force into two components, then you would need to learn that first before jumping into solving problems on solid friction. There are videos in our channel discussing the force resolution into two components, basically x and y, or any planes basically. So you can have a look at it before you proceed into this video. So the problem we have here is as given here. There is a solid body here which is on a plane inclined at 15 degree to the horizontal plane. So you have your horizontal plane here, you have your horizontal plane in here. So this is your horizontal plane, and you have a plane inclined at 15 degree to the horizontal. Now the question is, at this condition, a 200 Newton force can balance the body at equilibrium, or is this is enough to just to keep the body at equilibrium. Now if the angle is increased to 20 degree, then the effort needed here to keep the body here is 230 Newton. So if the angle of inclination is made 20 degree, the effort to just move the body is 230 Newton. So what's the weight of the body and the coefficient of friction? Now it's all shown in here. You have the solid body here, you have a 200 Newton force acting here to keep the body in equilibrium at 15 degree, and as you know, the body is trying to move upwards with this force, and therefore the friction will be opposing that movement. And I've shown friction here, the frictional force here, F1, which is acting against the motion of the body, and you have the weight of the body acting from its center of gravity vertically downward, which is W. That's what you need to find out, and also you need to find the friction coefficient. Now you will need to resolve, you can resolve this to either to this plane or to this plane. Okay, you can either resolve to this horizontal plane or onto this plane, but because you have the forces parallel and more forces parallel and perpendicular to this plane, it would be easy if you resolve the forces, the forces at an angle onto this plane rather than onto this one. Let me make this clear. You have a 200 Newton acting parallel to this force, this plane, and a normal reaction acting perpendicular to this plane, and again the force of friction acting parallel to the plane inclined at 15 degree. So 1, 2, 3 forces acting either parallel or perpendicular to this plane, and that's only one force, W, is acting at an angle 15 degree to the normal of this plane. So that's the only force that you need to resolve if you calculate all the forces based on this plane. So if you want to resolve this force onto this plane, that means you will have two components of this force. One will be parallel to this plane and the other will be perpendicular to this plane. And then that's it done. You have solved the problem. That's all you need to do to solve this problem. Now let's move on. I've shown a different figure here showing how to resolve that forces. So just to make what I discussed previously a bit more clear, this is the force which is inclined at 15 degree to the normal of this plane. Now you have to resolve that force onto this plane. So you will need one parallel component and one perpendicular component to this plane. So this force have a perpendicular component which is W cos 15 and a parallel component which is W sin 15. So this is the force opposite to this angle, and this is the force adjacent to this angle, to this 15 degrees. So you have cos 15 here and sin 15 here. Now that's it. As I said before, the equilibrium conditions are all discussed or described in this figure. So you are finding the equilibrium, or you're balancing the forces based on this plane. So when I say x-axis, it will be this one, not this axis, because you're doing your calculation based on this angle. And when I say y-axis, it will be perpendicular to this plane and not to this plane. So make sure that you understand this. You are resolving this force onto this plane, the plane inclined at 15 degree. Now for the first case, you have 15 degree and 200 Newton. So let's call it case 1. 15 degree inclination and 200 Newton force. So what you have there is it's all as I said before, it's all mentioned there. You have to find the force equilibrium, which will give you summation of forces in x direction equal to 0, and that is x direction is this direction. So you have a 200 Newton, and you have a this force here, W sin 15, and you have the force of friction. So F1 and W sin 15 acting in the negative x direction, and 200 Newton is acting in the positive x direction. So you have 200 Newton is equal to F1 plus W sin 15. Now you know F1 is mu R1, so you have that is equal to mu R1 plus W sin 15. This F1 is equal to mu R, is discussed in the previous video of friction. So force, the frictional force is coefficient of friction into the normal reaction. So that is mu R1 W sin 15. That's the first case. So you have 200 equal to mu R1 sin 51. Now that is a horizontal balance. Now you have summation of forces in y direction equal to 0. That will give you the only forces perpendicular to this plane are R1 and W cos 15. So that will give you R1 is equal to W cos 15. So you can substitute the value of R1 in here, and that will give you, let me just drop it slightly down, so that you have, if you give the R1 here, you will have 200 equal to mu into W cos 15 plus W sin 15. That will give you W into mu cos 15 plus sin 15, and that's 200. So let's call it 1, and then let's move on. Well, you don't have to repeat the same thing again. The only thing that we change here is the force and the angle. So in the question you have a 20 degree and 15 degree and 200 Newton, and 20 degree and 230 Newton. So instead of 15 degree, the angle will change to 20 and the force will change to 230. So based on the same analogy, you have 230 is equal to W into mu cos 20 plus sin 20. So let's call that 2. So if you divide 2 1, I mean equations 2 over 1, you have 230 over 200, that is 1.15 is equal to, W will be cancelled, and you will have mu cos 20 plus sine 20 over mu cos 15 plus sine 15. Now it's only mathematical operations to solve the problem. So you have 1.15 times mu cos 15 plus sine 15 is equal to mu cos 20 plus sine 20. I just rearranged it, took this one to the other side of the equation. Now taking the cos terms altogether to one side, you have 1.15 mu cos 15 minus mu cos 20 is equal to sine 20 minus sine 15. Excuse me. And that will give you you can take the mu out of that, and that will give you mu into 1.15 cos 15 plus cos 20 equal to sine 20 minus sine 15, or mu is equal to sine 20 minus sine 15 over 1.15 cos 15 plus cos 20, and after calculation that will give you 0.2593. so that is your coefficient of friction. Now if you go back to the first equation, you have 200 equal to mu r1 plus w sine 15. Now r1 is w cos 15. So you have an equation here. You can either use 1 or 2, that doesn't matter. 200 equal to w into mu cos 15 sine 15, and now you know the value of mu, so you just need to find w, and if you repeat that equation here, you will have 200 is equal to w times mu cos 15 plus sine 15, or w is equal to 200 over mu cos 15 plus sine 15. Now you can substitute the value of mu in here, and that will give you 392.68 Newton. That is a W, and that is a coefficient of friction. So this is answer 1, and this is answer 2. This is coefficient of friction, answer 1, and weight of the body, that's answer 2. So once again, what you all need to do is to resolve the forces parallel and perpendicular to a plane. You can either balance it to this plane or to this plane. The reason why we balanced onto this plane is just because you have more forces parallel and perpendicular to the plane inclined at 15 degree or 20 degree. But if you consider this plane, every force is at an angle not parallel or perpendicular to this plane. So you will have only one force normal to this plane, but considering this plane, three forces are parallel and perpendicular, and you have only one force at an angle to this plane, and that's the reason why we chose this this plane to analyze on.